Hello friends, today we'll look into another item from effective Java. So this is regarding checking the validity of parameters for a method or constructor. So usually when we have methods, we have input parameters and we use those to do some computations, and probably we can return some results from the methods. And before using the parameters, we should check the validity of the parameters. So some of the parameters could be having the restrictions like let's say if it is an integer, it cannot be negative. Like let's say if it is representing an index in an array, so that cannot be negative. That should be 0 or greater than 0. So in those cases, we should check the validity. If we are not going to check the validity of the parameters, so they may propagate to bugs, and debugging that kind of bugs will be really difficult. So some of the times the programs may seem to work correctly, and at some other point of time we may get an bug, and it is very difficult to trace the root cause of an issue. So that may seem like some other part of the code may be giving the issue, but actual issue could be in the original method where the validity might not have been checked. So to avoid all these error cases and the bugs, so we should be checking the validity of the parameters. So Josh discusses different ways of checking the validity of the parameters for a method or constructor. Okay, let's understand how we can check the validity of parameters through some simple examples. In this case, I have a method m1 which is trying to compute the perimeter of square. So computing the perimeter of square takes an input parameter which is positive side value. So let's say if I give negative value, so what will be my result? So as you might expect, the result will come as -8, so which is not expected. So clearly this is an issue. So how we can avoid this at the first place? So before trying to compute the value, so we should avoid uh, the using value of this parameter. So how we can avoid? So we can put a check here saying that if side is less than 0, so we can throw illegal argument exception saying that side can't be negative, right? So I expect that if I give a negative integer, so it should throw me this exception. Let's assert that. So I am sending a side value as -2, and if it is negative, so I should be getting the illegal argument exception. Basically this test should pass. So yeah, so this test is passed, so that means this is throwing an exception. So there are different ways to validate. This is one of the way, and let's consider another example. So here I'm having student names as a list, and I'm storing them into a grade. So a grade have a list of students. So it's very simple class. So grade, which takes students names as an input and stores them, and you can add students to the particular grade, and you can also query for the students assigned to a particular grade. So to start with, I will add a few students S1, S2, S3, and assign them to a new grade, right? So let me print them. right? So far fine. So we got 3 students. Let's say I will add another student into the grade. Okay, by mistake or by other means, so I give the student name as null, right? So what will be the result in this case? So I will get the null. So this is not expected as the name of a student. So what should I do to avoid this? I should be adding a check here. If name is null, throw new null pointer exception, name can't be null. So this is one of the way. So let's say I run this again. So I get a null pointer exception. Name can't be null. That's fine. So there are different ways to throw this kind of exception. So this is little boilerplate. So starting from Java 7, we have a new utility class which is objects.require non-null. Let's see how we can use that. Objects.require non-null, name. If name is null, what should be my message? Name can't be null, right? So if it is non-null, I will get the name here as a result of this, so that I can use here, right? So let me run it again. So I got the exception here, and it looks more cleaner, less verbose. So we can use the objects.require non-null whenever we want to check for the validity of the parameters. So there are annotations at not null, and such annotations are also used frequently in the APIs, but they are not so much standardized. So in most of the cases for null check and index check, so we use these utility methods from objects. So we have different utility methods in objects class that we can explore, especially for index. Also for arrays and list, we have validating the index, so we can explore these methods from the objects class. Also note here, whenever name is null, so we are throwing a null pointer exception, and it is also advised, so whenever we are throwing an exception, it should be documented. So in one of the other items under exceptions chapter, I have discussed in detail about documenting the exceptions. So in brief, so we should be documenting here. The documentation for the method will go here, and also we should be documenting the method, like this is throwing a null pointer exception when name is null. So documentation is very much important, either it is checked or unchecked exceptions. So validating the parameters also applies to the constructors. Let's say in this case the students list is null, so we should not be storing the student list as null as it is here. Before storing here, we should be checking the validity of the list. So similar way we can check the require non-null students. So to be brief, we can have this within the method itself. As we saw till now, so we can have at the beginning of a method to check whether the parameters are valid or not. This is one of the way. So another way is, in some cases, checking the validity of parameters will be expensive. For example, let's say we have a method in JDK collections, and let's say sort method, right? So in the sort method, it takes input as a list of elements. So checking validity of each and every element in the list will be very expensive. In these cases, what Josh recommends is we can depend on some of the computational methods uh, so that they can check the validity implicitly. For example, in this case, when we say sort, so internally when it is going to sort, it will be using the comparable. So in those cases, it will be checking the whether the objects are of the same class type. So if they are not, then it will throw a class cast exception. So implicitly it is checking the validity of the parameters, but we should take care of one thing here. So whenever we are depending on the computational methods to check the validity, we should not be over dependent on those methods. So there is a word of caution if we are over depending. So there could be cases like where we will break the failure atomicity. So I have discussed about failure atomicity in one of the items under exceptions chapter that we can look into. Basically, failure atomicity is about retaining the invariance of the class. Let's say, for example, if we have a class employee, right? So employee have name and his salary and other details. Let's say you are going to update his salary details, and by some reason you get an exception during the updating of the salary, and you throw an exception with a message saying that not able to update the salary because of some reason, right? So in that case, the employee salary should not have been updated and it should retain its previous state. So invariance is about retaining the state of an object. And in some of the cases, when we depend on computational methods to validate the parameters, in some cases they may verify the validity, but the exceptions which are thrown by those computational methods may not be relevant to the context of your method. In those cases, we should be depending on exception translation. I have again discussed about this under exception chapter. So exception translation is about translating the exceptions. Let's say computational methods throw some lower level exceptions, we should be converting them into a higher level exceptions which is relevant to the context of your API. So in summary, this item discusses about validating the parameters, and we should not take it for granted that we should check validity of each and every case for the parameters. So generally the API should be generic enough so that they inherently handle these conditions. The use cases which the APIs implement, they should take care of invalid parameters. So in some cases, when the use cases doesn't apply to the invalid parameters, in those cases we should be throwing the exceptions. And also remember, we should be documenting the exceptions. Also note in some of the classes, let's say for example this class big integer, so Josh discusses about this numerical classes a lot because he is one of the author of these classes. So anyways, so in these classes you can see that we are documenting some of the exceptions at the class level. If most of your methods are throwing some common exceptions, so instead of documenting them at each and every place of the method, so we can document them at the class level. So takeaway from this item is document the exceptions, validate the parameters before using them, and we will see in the next item there is a very important aspect of why we validate the parameters, that is about the security. So we will discuss about it in detail probably in the next item. Thank you.